Hello viewers, today we are going to discuss about nodal analysis. Before analyzing the circuit, let us see some basic concept. Consider this is a given circuit. In the given circuit, you need to find out the current I. So how will you find out the current I? We know very well, according to Ohm's law, I equal to V by R. I equal to V by R. V is nothing but it is a potential difference between 2 points. So here, 10 volt is the battery. It means battery has two terminal, one is positive, another one is negative. Let us assume the positive terminal has plus 10 volt potential and negative terminal has 0 volt potential. So the potential difference is 10 minus 0, you will get 10 volt. So I equal to V by R. So potential difference between these 2 points across the resistor is, it is 10 minus 0 divided by your resistance is 10 ohm. So you will get 1 ampere of current. In the second example, the one end of the resistor is connected to plus 10 volt. It is 0 volt. The other end of the resistor is connected to plus 5 volt. It is 0 volt. So 5 minus 0, you will get 5 volt. Here 10 minus 0, you will get 10 volt potential difference. Okay. So the first end of the resistor is connected to plus 10 volt potential. The second end of the resistor is connected to plus 5 volt potential. Then according to Ohm's law, I equal to V by R. Then what is the potential difference across the resistor? 10 minus 5. So it is 10 minus 5 divided by your resistance is 10 ohm. So 5 by 10, you will get 0.5 ampere. But here in the third circuit, we have same 10 volt battery and 5 volt battery, but look at the 5 volt battery polarity. The polarity is reversed, negative plus. So in this case, you need to find I equal to, the one end of the resistor is connected to plus 10 volt, the other end of the resistor is connected to negative. So you have to find out the current in this way. I equal to V by R. So here the potential is 10 volt. So 10 minus of, the second end is connected to negative terminal. So we consider it is minus 5 divided by 10. So 10 plus 5 divided by 10, it is 1.5 ampere. So this is the concept behind nodal analysis. So here you have to consider this potential is minus 5, this positive potential is 0. So that's why it is 10 minus of minus 5, it will become plus. Okay, now come to the problem. So in the given circuit, you need to find out the current flowing through the branches using nodal analysis. Okay. So what is the first step in nodal analysis? The first step for nodal analysis, you need to identify the number of nodes. So the node is nothing but two or more circuit element meeting point. So this is your first node, second node, and the third one is your reference node. So look at the circuit. So here we have one node and we have another node, but the two nodes are connected by a common wire. So we consider these two nodes as a single node. So it is a reference node. The first point, identify the number of nodes in the given circuit. So node 1, node 2, this is your third node, node 3. Second step, you have to assume the node potential. Node potential now. So here first node potential is V1, second node potential is V2. Assume the reference node potential is 0. The reference node potential is 0. So this is our second step. Third step, assume the branch current. Assume the branch current now. So here one branch, second branch, third branch. So each resistor is a branch. Consider as a branch. So in the first branch, the current flowing is I1. This current is divided into I2 and I3. This I3 current is further divided into I4 and I5. So first step, identify the nodes. Second step, assume the node potential. Third step, assume the branch current. You can assume the branch current in any direction. Okay, so here I1 is incoming current, it is divided as I2 and I3. Again I3 is divided into I4 and I5. Irrespective of the battery polarity, assume your own current direction. So next step, you have to apply KCL for individual node. So in node 1, so this is our first node. In node 1, apply KCL. KCL means Kirchhoff's current law. So in a node or junction, sum of incoming current equal to sum of outgoing current. So this is KCL. So look at the node 1. So what are all the incoming currents with respect to node 1? Your I1 is incoming current and I2 and I3 are flowing away from the node. So I1 equal to I2 plus I3. We can write I1 equal to I1 is an incoming current. It is towards the node, but I2 and I3 are away from the node. So I2 and I3 are considered as outgoing current. So we know very well by Ohm's law I equal to V by R. I equal to generally V by R. V is nothing but potential difference between 2 points divided by resistance. Your I1 current is flowing from positive terminal of the 100 volt battery to V1 potential. Now the current is flowing from plus 100 volt to V1 volts. So the potential difference is 100 minus V1 divided by the resistance is 20 equal to your I2 current is flowing from V1 potential to 0 potential. So potential difference V1 minus 0 divided by 10 plus your I3 current is flowing from V1 to V2. So potential difference is V1 minus V2. So V1 minus V2 divided by 15. Solve the equation, you will get 0.216 V1 minus 0.067 V2 equal to 5. So this is our first equation. Similarly, in node 2, so this is our second node. In node 2, apply KCL. So what is KCL? Sum of incoming current equal to sum of outgoing current. So with respect to node 2, your I3 is incoming current. I4 and I5 are away from the node. So I4 and I5 are considered as outgoing current. So incoming current equal to I3. Your outgoing currents are I4 and I5. So it is sum of outgoing current. So I4 plus I5. We know very well by Ohm's law I equal to V by R. Your I3 current is flowing from V1 to V2. So the potential difference is V1 minus V2 divided by the resistance 15 ohm. So V1 minus V2 by 15 equal to, what about your I4? Your I4 current is flowing from V2 potential to 0 volt. So potential difference is V2 minus 0 divided by the resistance 10 ohm plus I5. Look at the current I5. Your current I5 is flowing from V2 potential to minus 80 volt. It is negative terminal. So V2 minus of minus 80. V2 minus of minus 80 divided by the resistance is 10 ohm. Solve the second equation. You will get 0.067 V1 minus 0.267 V2 equal to 8. Let it be equation number 2. Write the two equation in matrix form. Write the two equation in matrix form. 0.216 minus 0.067 and 0.067 minus 0.267. The unknowns are V1 and V2 equal to, the constant terms are 5 and 8. 5 and 8. Using Cramer's rule, solve V1 equal to del V1 by del, V2 equal to del V2 by del. You will get V1 equal to 15.02 volt and V2 equal to minus 26.19 volt. After finding V1 and V2, you can easily find out the current flowing through the branches. So how means, we know very well I1 equal to what? I1 equal to 100 minus V1 divided by 20. So I1 equal to 100 minus V1 by 20. So 100 minus, substitute V1 15.02 divided by 20. Solve this, you will get I1 value. Similarly, if you want to find out I2, what is the formula for I2? Your I2 equal to V1 minus 0 divided by 10. Similarly, substitute V1 value 15.02 minus 0 divided by 20. You will get around 1.502 ampere. Similarly, I3 equal to V1 minus V2 divided by 15. And I4 equal to V2 minus 0 divided by 10. I5 equal to V2 minus of minus 80. It will become V2 plus 80 divided by 10. Solve it, you can find out the individual branch currents I1, I2, I3 and I4. Suppose if you want to find out the power or voltage drop across 10 ohm resistor, mean just multiply I2 and 10. So I2 into 10, it will give the voltage drop across 10 ohm resistor. Suppose in case if they ask you to find out the power dissipated by 10 ohm resistor, you have to use this formula P equal to I squared R. So the current flowing through 10 ohm is I2. So I2 square into 10 ohm, it will give you the power dissipated by 10 ohm resistor. Similarly, you can find out the power dissipation for remaining resistors. So this is how you need to find out the current flowing through individual branch using nodal analysis. Thank you.